Hello, my name is Vicente Almeida, and this is RL T2F, an interactive system for reinforcement learning-based feature selection for multivariate time series clustering. It is available online via the link rl-t2f.streamlit.app. With our system, the user can train a reinforcement learning agent to learn to select the best features in order to cluster the available time series. At each step, an agent selects a feature, and the system repeats the clustering using this newly added feature. Unsupervised clustering metrics are then normalized and applied to the novel clusters, and the reward received by the agent reflects how much the average of the scores increased or decreased. On the left panel here, we can select different data sets in reinforcement learning agents, set the number of episodes to train the agent and the maximum number of features to be selected in each episode, as well as configure the agent's hyperparameters and the early stopping criteria. The idea for the early stopping is that if the system notices that the features that the agent is selecting aren't improving the quality of the clusters, the episode is terminated. This helps to restrict the size of the set of selected features, which increases the interpretability of the results. The system offers two different running modes: automatic, where the user can choose to automatically train the agent for a given number of episodes, and step-by-step running mode, where the user can run the training episode by episode or step by step. For the automatic mode, we simply choose how many episodes the agent should train for and click on Train Agent. The system automatically trains the agent for the given number of episodes, as we can see here. With the step-by-step method, we can simply run one full episode at a time, or even run one single step at a time. This allows for a stepwise visualization of how the agent learns and selects features, and also helps with debugging, the learning, and performing manual hyperparameter tuning. Also, the stepwise method allows the user to replace the automated early stopping with a manual early stopping criteria, thus introducing a human-in-the-loop component to our system. At each run, the four expandable visualization sections automatically update to reflect the current state of the iteration. In the first section, we can see the agent's performance for the current episode, where we see the current value for each of the four unsupervised metrics that form a composite reward function, as well as how these metrics changed at each step of the current episode. We also display a plot with the cumulated reward of the agent, step by step. In the second section, we can see the global performance of the agent with the final unsupervised metrics and the total reward received for each episode. The third section shows the list of selected features as well as the value of each selected feature for each time series. The final section shows the adjusted mutual information score of the resulting clusters as well as visual plots of the time series in each cluster. Since we are dealing with multivariate time series, the interface allows the user to visualize each dimension of the current dataset by selecting the signal of interest. The ground truth is shown by the colors of each line as well as a tooltip. The more homogeneous the colors in each cluster, the more accurate the grouping has been for that respective cluster. Additionally, an interesting functionality is the ability to set an upper limit on the number of features that the agent can select. I'll reset the system and run again to show an example. Here you can see that the number of features was limited by what I said in the slider. There are also two different feature selection modes. The current tab which I just presented contains the automatic feature selection mode, where every single feature is selected by the reinforcement learning agent. The second tab contains the user-based feature selection mode, where the user can select which features should be fixed, thus every episode starts with these features already selected. Here, for example, just by selecting these features, the user can look at the different plots and see how the manually selected set of features is performing. The user has the same reinforcement learning functionality as in the previous tab, being able to run the training multiple episodes at once, or step by step. The main difference in the visualization is that in the list of selected features, the interface adds a background color to the features that the user manually selected. The final tab here shows a clustering ground truth of the current dataset for each possible dimension of the time series. Thank you.